Okay, our last example from yesterday's lesson. Example 4, a builder must fence 3 adjacent rectangular building lots on Foreman Ave. Each lot must have an area of 405 meters squared, and front fencing costs $20 per meter. Side fencing, the outer sides, costs $15 per meter, and the interior and rear fencing costs $10 per meter. So we want to know what shape for the 3 lots gives a minimum fencing cost and what is the cost. So we're going to try to draw a picture of the information that was given here. It says we want to build 3 rectangular building lots. I should say given. So I want to draw 3 rectangular building lots. Now I don't know how maybe the length is actually bigger, maybe the width is actually bigger, I'm not sure, but I'm going to take this section of land and cut it into 3 lots. Now these lots have to have the same area, and since they all have a constant width, I can tell that the lengths also have to be the same. So here I'm going to call the width y, and the length of each of the lots then has to be x because it says that they all have the same area. So I've labeled my lengths in black, and I'm going to label the prices in another color just so that I can make sure that I'm relating all the lengths with the prices. It's talking about having a front of each of these lots. So each of these lots must front onto the road. So I'm going to call this side the front and this side the back. And what I know then is that the front fencing costs $20 per meter. So I know that this chunk of fence here is going to be $20, $20, and $20 times the length. Now, the side fences, the outer sides, cost $15 per meter. So the outer sides are each $15 per meter. And then the inside and the rear are both $10 per meter. So the inside and the rear sides, they're all $10 per meter. Now what the question is asking me for is the minimum cost. So the thing that I want to find is the minimum cost. That means I need to come up with some sort of equation for cost. So what do I know so far? I know that the total cost of this of the fencing going around these lots is going to be across the front 20 times the length x, 20 times the length x, and 20 times the length x, or altogether 60 times x. And then looking at the back of the lot, I've got 10 times x, 10 times x, and 10 times x, and that all together will be 30 times x. And then I'm going to look at the outside pieces. The outside pieces are 15 times y, and then the other side 15 times y. So that's altogether 30 times y for the outsides. And then the interior sides, there's only 2 of them. They separate the 3 lots. That's 10 times y and 10 times y, which is 20y. Now I can simplify this to 90x plus 50y. So this is nice, but it still has 3 variables, and I know I want to get it down to 2 variables. The other piece of information that they gave me in the question is that each of the lots has an area of 405 meters. So I know that the area of each of the lots is the x times the y, and I know that the area has to be 405. So I can use this expression to simplify my cost expression down to 2 variables, cost and one of the others, x or y. So I'm going to do cost in terms of x, which means that I need to get rid of the y. So over here, I'm going to solve so this looks like y equals. So I get 400 over x. So subbing that into my cost formula, that's 90x plus 50 times 405 over x, or simplifying that 90x plus 20,250, and I'm just going to move the x to the top and give it a negative exponent, so it's a little bit easier for me to take the derivative. So next I am going to take the derivative. So taking the derivative of the two parts, because I've got addition between them, the derivative of 90x is 90, and then here I bring the negative 1 down front, so I've got a negative now, and then 20,250 times x to the negative 2, or all over x squared. Now I want to set that derivative equal to 0. So I'll move the 20,250 over x squared to the left-hand side. That equals 90. And then I'm going to multiply the x squared up to the right. And at the same time, I'm going to move the 90 to the other side by dividing it. And I can see that x is going to equal plus or minus this fraction, the square root of this fraction, sorry, which is equal to plus or minus 15. But negative 15 is outside of our interval because we know that x has to be greater than 0 since it is a side length. So it says, what shape for the 3 lots gives the minimum fencing cost? We will check the prices at each of those intervals. So I will check the cost at 1, the cost at 15, and the cost at 405. And I actually don't have these calculated, but what I'm going to find is that the minimum cost comes from the 15. So I'll just substitute these in. In the first one, I get 90 times 1 plus and then I'll keep substituting those in. So next I'm going to do 90 times 15 plus and I can see there that my minimum cost is given when the shape of the lot is 15 for the x. Now part A actually asked me for the dimensions, so I do need to find both the x and the y. Now remember that we had that expression for y, that y is equal to 405 divided by the x, or divided by 15. And so I get that y is equal to 27. Therefore, the minimum cost, I'm going to answer part B here at the same time. The minimum cost of $2,700 is All right, and then just to remind you, our homework is there. Have a good day, guys.